If you've ever spent hours wrestling with a large language model, you know the feeling, right? It works perfectly 1 minute, and then the next, it just falls apart. You realize pretty quickly that a good prompt just isn't enough. So today, we're going to talk about moving beyond those simple chats with AI. We're diving into how to build robust, engineered systems, what some are calling an AI harness, to make these models truly reliable and powerful. Let's get into it. This quote from the dev community it absolutely hits the nail on the head. It perfectly frames the huge shift that's happening right now. The real challenge isn't about finding the perfect magic words for a prompt anymore. It's about building a smarter container, a better system for that magic to happen in, consistently and reliably every single time. So let's start by talking about the pain points, because we've all been there. You've tinkered with a prompt for hours, you've tweaked every single word, and then you try to use it in a real application and poof, it's brittle, it's unpredictable. That right there, that's the limit of basic prompting. And it's exactly where the real engineering has to begin. And this table just lays it out perfectly. The old way versus where we're all heading. We're moving away from these fragile, one-off prompts that are all about the wording, and we're moving toward robust, orchestrated systems that are built for continuous, nonstop operation. This is that crucial leap from a cool little demo to a production-ready tool that has safeguards like verification loops and schema checks built right in. And this isn't just some abstract, theoretical problem. The costs here are very, very real. I mean, if you're running a continuous agent system using one of the top-tier, frontier models like Claude Opus, you could literally be burning through hundreds of dollars every single day. Without that smart system design, you're not just getting unreliable results, you're paying a huge premium for them. And this just perfectly captures the feeling that's driving this whole change. You can feel the frustration. The community is just tired of reinventing the wheel, of writing endless boilerplate code, and dealing with these low-level tools that just aren't built for scale or efficiency. That frustration, that's the engine of innovation that's pushing all of us toward better frameworks and a whole new way of thinking. Which brings us to a really crucial shift in the entire landscape. See, as the basic act of generating code or text gets cheaper and easier, the skills that truly matter are starting to change. The real value is moving up the stack. So here's the key takeaway. When anyone can generate code in seconds, the person who knows what to build, how all the pieces should fit together, and where the potential pitfalls are, well, that person becomes exponentially more valuable. Remember, making bad decisions gets cheaper and faster too, which makes having good architecture more important than ever. I absolutely love this perspective. This isn't about de-skilling developers, it's about upskilling them. The job itself is evolving from pure execution, being the fastest person at the keyboard, to system-level oversight. Can you define the problem correctly? Can you set the right constraints? Can you anticipate the failure modes? That's the new high-value work. It's basically a promotion from builder to architect. Okay, so how are developers actually doing this? Let's get into the nitty-gritty, the toolkit and the concepts people are using to build these new, more reliable systems. It's all about creating a better harness for the AI. This harness metaphor is just perfect, isn't it? The big labs can build the raw horsepower, the giant engine, but the real leverage, the real power, comes from the supportive structure you build around it. A well-designed harness with things like better task framing, iteration loops, and tool access can make a good model perform like an absolutely brilliant, much more capable system. Now, a key part of that harness is the MCP, or Model Context Protocol server. The best way to think of it is like a universal adapter for your AI. Instead of jamming every single tool and API definition into the prompt, which just clogs up the model's short-term memory, an MCP server lets the agent just ask, hey, what tools are available, and discover what it needs on the fly. This is an absolute game changer for building scalable agents. Another really powerful tool is the Graph Database, or Graph RA. Think of this as giving your agent a super sophisticated long-term memory. Instead of just doing a simple text search through a pile of documents, you can index your entire code base or your whole knowledge base into a graph. This gives the AI a deep, relational understanding of how everything is connected, and that leads to much, much smarter retrieval and analysis. And of course, the community is already building on these ideas. We're seeing these higher-level frameworks start to pop up. Things like Hyperterse, which lets you declare your tools in simple files, or the Rust MCP core, which lets you spin up a whole server with just a few lines of YAML. The goal for all of them is the same:
cut down on the boilerplate, and let developers focus on the actual logic.
All right, so let's see how all these pieces can fit together in a truly mind-blowing case study. The MiroFish engine is just a fantastic example of a complex AI system that goes way, way beyond a simple prompt. It uses swarm intelligence to do something pretty incredible. The goal of MiroFish is, well, about as ambitious as it gets: to predict the future. And it tries to do this not with one single giant model, but by harnessing the power of thousands of interacting AI agents. So this is the core concept: swarm intelligence. You feed a real-world event, say a news story or a new policy proposal, and it spins up an entire parallel digital world. Then it populates that world with AI agents, all designed to react and evolve. The prediction isn't a single answer from one model. It's the collective outcome, the emergent behavior of how the entire swarm reacts. It's kind of like predicting a traffic jam by simulating thousands of individual cars, not by asking some all-knowing oracle. And here's the workflow. Now notice step 1, it starts by building a graph RAG, just like we talked about, to create that rich relational context. Then it sets up the world, runs the simulation, and even has a dedicated agent just to analyze the results. And this final step is brilliant. You can actually go into the simulation and talk to the individual agents to understand their reasoning. This right here is AI systems engineering in action. So, what does this all mean for you, for the developer building things? Where is the real, durable value in this new era of AI? Let's wrap this all up with what I think is the most important takeaway. I find this quote so incredibly empowering. You don't have to worry about competing with the giant labs building the base models. They're basically creating a new utility, like electricity. The real innovation, the real value is in the application layer. It's in building the specific, useful cars that run on that engine and actually go out and solve real-world problems. And that really brings us to the final crucial point. Your competitive advantage, your moat, is no longer just about what you know. It's about knowing how to use this new utility of intelligence effectively. It's the ability to design, to orchestrate, and to constrain these incredibly powerful models to produce reliable, valuable outcomes. So, as we've seen, the whole game is changing. It's becoming less about the prompt and way more about the platform, the system you build around it. The most valuable skill is quickly becoming the ability to architect these systems well. So the only question left is, where are you going to build your harness?